this, yeah. Okay. So, I like to take photos. Can you see this over here? Or no?
Yes.
Okay. Let's see if we can do this.
Like put your, yeah.
So if we have a causal loop diagram. What's that?
Yeah.
All right. Oh,
I'll turn light there.
good, good. Okay, let's call this. Get two. Maybe we should start even simple. Let's take two like this. Two causal. Here's A. And we'll consider it as having a plus. And here's B. And we'll consider it as having a plus as well. Maybe we'll just start there. So what is the product of each of these? Let's draw it suggestively over it. This gives it the product, right? And remember, product is such that we have to have these morphisms. What are these morphisms here? These are homomorphisms between stock flood diagrams.
Both have plus, right?
They both have one. Right. What? Okay, so I'm trying to start simple, right? I'm trying to make a point here. So this has to be such that it can project down to this.
Yeah.
And it can project down to it, right?
Mm-hmm.
So what are its variables? I'm telling you, it's going to have a variable A, B. It's going to have a variable for each of these multiplied by each of the Cartesian products of variables. So it's going to be one that's like A, B. And it's going to have a plus. Guess what? And this is a homomorphism now to that, and it's formed that. But now let's imagine we have A, and maybe we'll have, I should have called this one, just so we can by the name know which one it came from. Call this A1. Are we okay with that? Okay. Now we have A to B. Each of these has a plus. And this is a minus sign. No, let's not even have a look for now. Let's just leave about it without it. You'll see another thing. And this was going to have one. What would the product be here? By the way, this can all be done in CATLAB. You can just say like go compute the products, right? What would this be? Well, sorry, two variables. And what would they be? What might we name them? A1 and B1. And this one is going to be a plus. This one is going to be a plus. This is like projecting down to this. Yeah, okay. This is projecting down to that. Both of these go down to that, right? This is a homomorphism. So a homomorphism, a causal homomorphism can map both of these objects down to this one. And both of these plus arrows to this plus arrow. Are we okay with that? Okay, let's, so we're on a roll. Now let's consider. I'm just building up complexity here. Let's consider one where we have A and B. The plus. And then we have 1 and 2. We have plus. We'll be dealing with the links in a minute. And you'll understand why I'm putting these things in there, but I'm just trying to build up some intuitions. Now we have to have these are again causally homomorphism, right? So how many objects are there now? 4 objects. What are they? Yeah.
I'm thinking about semantics, like a real causal diagram. You have to interpret the product of causal, whether it makes sense.
Oh, it does. I'll tell you now. In just a minute. Yeah. And then we have groups for each. It does. I'll tell you one in just a minute. So what does the homomorphism this way do? What does it do? From this whole thing, what does it do? Well, it projects out something. What does it project out? Basically, these things do. It projects out this dimension, right? 1, 2. And so this one gets mapped to A, this one gets mapped to A, this one gets mapped to B, this one gets mapped to B. And what does it do this way? It goes like these two get mapped to 1. Oh, sorry. Yeah. These two get mapped.
A1, B1, B1.
Yeah, A1, B1. So I said that. So this, yeah. This whole column gets mapped to A, this whole column gets mapped to B that way. So mostly homomorphism here. This whole row gets mapped to 1, this whole row gets mapped to 2. Are we okay with that? Okay, now what could this possibly mean? Well, look, if one group is talking about a causal loop diagram, this is really maybe silly, but they're talking about the situation in Saskatchewan, the situation in Alberta. And this one's talking about for people born in Canada and people not born in Canada or something like that. Now we have a causal loop diagram, which is considering like the situation for Saskatchewan for those born in Canada, the situation for Saskatchewan, for those not born in Canada, the situation for Alberta, born in Canada, the situation for Alberta, not born in Canada. Something like that for those. Okay. So like you'll start to think of these as stratification dimensions potentially. Now let's continue building up though, because
during your
yeah
class about how it was so tedious to
that's right.
think of it in the stock and flow diagram purpose.
That's right.
You have to have all these separate.
Totally. This is very much a product thing because you have to have all the product. So, okay, now let's think about where these. That's right, exactly like that. Exactly that. All right, let's think about what these. What's in mine? No. And we have maybe 1 and 2 here just as object. Trying to build up. There we go. Here we go. I'm not actually sure, is the glare an issue? If I turn this on, like, is it glary?
Yes.
It is glary.
I was trying to find a way to prop up your laptop so then it wouldn't have a. Like,
The glare issue?
yeah,
Yeah, it's a good idea.
there's boxes, but they're not full enough. I think the laptop might sink in.
Oh, yeah. Yeah. Okay, so let's think about products here. First of all, what are the objects here? Products of the object. But, and we have to lose. I'm tempted to not even start to draw them. But what are we gonna do with this arrow? What does it apply for? Well, look. This is so
It's only gonna be-
you got the right idea.
You won't be any diagonal.
Okay. So you're getting the right, you're getting a fruitful way of thinking about it. It goes between, which way does the arrow go here? So are there arrows between objects? Yes. Which way do those arrows go? Well, they go from A to B.
Or, yeah, because in the original set it's A to B.
Okay. So does it go A1 to B1?
Yeah.
Does it go A2 to B2?
Yeah.
Yes. The minus one there. Does it go A1 to B2?
No, because we can't protect that down.
Yeah. Yeah. Okay. You're thinking well ahead. This is awesome. That's right. Let's I was gonna suggest we do that. Okay, so this one, like before, it will quash down the rows. We'll go like that. And this one will like quash down. Okay. So wait a minute. Okay. I'm having a short circuit here. No, that's right. This will quash down the column, right? So A1 and B1. Oh, okay. We need something else though. Oh, darn it. I have to go find out. What do I need for every object? What do I need? So what I'm telling you, I'd like to be able to quash this down like that, so that the ones go to this and the twos go to that. But what's going to happen to the minus arrow? It's just going to be on that, so there's no minus arrow to receive it. Right? There's no minus arrow for each of these. So actually, all of these guys need like minuses. Sorry, I hate to
Yeah,
disappoint you.
remember our schema, right?
Yeah. These all have like
Yeah.
mine. It's like a little
Big
bouquet.
support narrative.
Again, you can start to see why people don't even draw them. But the point is, it is needed because we're going to need it in order to quash down like that. Now we're going to have a link from this. There's going to be a self link here. That's going to come up. I'm gonna. So there's going to be plus and minus links here. But do you see why that's needed? Why that minus link is needed? Because if you quash along this way, this link doesn't go nowhere. I mean, it's a graph, it's a causal loop homomorphism. So the link has to map onto a link here. A negative link has to map onto a negative link. And because these are being squished into one, there has to be a negative link from 1 to 1. And there has to be a negative link from 2 to 2. Are we okay with that? Now, so here you could say there's people, the situation in Alberta does something to the situation in Saskatchewan, and so this is negative link here, and it applies for both of people who are born in Canada and people who aren't, or something like that. Hmm? Okay, so let's continue. Can we continue? Okay, now let's suppose we were to think. I'm just going to draw this increasingly schematically. So we have this minus link here. And well, yeah. You tell me if we added a plus link here, even let's be a bit fancy. Suppose we had added a plus link from B to A. How would that translate to here? We'd have a plus link for each of these layers, each of these strata, right? Stratum, each of these is a stratum. And then that plus link would map to this guy here and this plus link. Okay, now let's suppose though we have a minus. Well, let's suppose just to make them more obvious as a plus link here. This is AB like before. This is 1, 2. What does this look like now? What does it look like now?
We have some objects areas, variables, and in plus and in minus are objects. We can have a set of objects for variables, set of objects for minus, and set of objects.
Well, okay.
And project that is set together, actually, for example, for variable, you put like two set together. You actually 4, for example. And for minus thing and plus thing, you can product two set. So if you could take two Causal.
Well, remember here, so I'm not sure. I may be wrong, but there may be a level issue here where, so we're dealing here with causal loops, and we're abstract away from the particulars of like each of these might be encoded using a causal loop schema or something like with objects. Here, though, we're operating in the category of causal loop diagrams. So each of these morphisms, each of these morphisms this way is a morphism between whole causal loop diagrams. So we're like, these are not objects I'm drawing, they are variables in a causal loop diagram. And these are like homomorphisms between causal loop diagrams. You're right that if we went inside like the implementation of this as like a CSAT, there's probably some story about what's going on there, which is interesting. But I will say one of the nice things about this is that, like, when you're operating with causal loop diagrams, you don't have to worry about how they're performed. And actually, you can perform categorical operations, like say, take this causal loop diagram with the product of this one, and it will actually produce this is in CATLab, for example. It will produce a causal loop diagram. It's a product. And you're probably right that in terms of the implementation, there's some story to what's going on. I'd have to think about it, but there may be some product-y story. I'd have to think about. But I just want to ask, what's the structure of this causal loop diagram? What would it look like? We saw what it looked like when we had just this minus here. What does it look like here? Well, this is A1. This is B1. B1. A2, B2. What does this look like?
The minus arrow from each A to its corresponding.
That's right. There's a minus one here. And where else do we have arrows?
So the plus or minus 1.
There's plus. Right, it's
We want to over plots.
like this, right? Like that, right? And now projection down would involve swishing this down to like rows. The two rows would collapse into one row for this. The two columns would collapse into one column for. But wait a minute.
No, it's the
No.
A1, A2 map to A.
Sorry.
Vertically.
Yeah. Okay, sorry, I'm turning it. Right. This row goes to that one. This row goes to this one. This way, this column goes to this one. This column goes to that one. And so these are like plus links here, right? Now, right. So you could see this this should sort of smell to you like the situation with sets. Like it's very similar to like Cartesian product of two sets, right? Like we have a Cartesian product of set 1 AB with 1, 2, right? We get this table, right? Where we have like, we can do it A, B. So A1, I'm going to put it as pairs because that's how we prefer to think about it. It's sort of pair of A, comma 1, pair of B, comma 1, pair of A, comma 2, and B, comma 2. And this is just dropping the second element. So the whole column, we just drop the second element. This one is dropping the first element, right? Just drop A, B, you get 1, and drop A, B here, and you get 2. So it's kind of smells like it, but one thing I'm kind of banking on here. So maybe I'll ask, I should have asked at the beginning, but in causal loop diagrams, if we think about the terminal causal loop diagram, what does that look like? What does the terminal causal loop diagram look like?
Oh, one variable and problems.
One variable. Let's remind you a bit of singleton, right? But it needs a plus
The minus.
and a minus. Why does it need both of those? Well, any other diagram, any other big diagram with lots of things in it and pluses and minuses, all those variables have to collapse down to this one. And any links between them, they may be plus or minus or plus or whatever. Those all have to be mapped, like all links between variables or variable to itself here have to map to them, right? They have to go somewhere. And this, all the minus have to go somewhere. And you can't map minus to plus, and you can't map plus to minus. So there has to be two of these, right? So there has to be like receptor capacity here. And you might think, oh, all we need is a singleton object, it's like singleton set, all we need is a variable. But no, you're not gonna be able to actually map on here because you can't map the links anyway, right? This is, yeah. So next time we'll talk about what's a coproduct of causal loop diagrams. Product of causal loop diagrams should remind you a lot of stratifying. Like you have these distinctions and you have those distinctions and they're orthogonal to each other. They're right angles to each other. You can distinguish these things and you can distinguish those things, and for every one of these you have this distinction. For every one of these you have this distinction, and so on. Coproduct will be very much like putting them side by side. Right? That's what we do all the time. And just like a set is a coproduct of little sets composed of each of its elements. The set is like you either have an A or you have a B. It's a sense of like you have to choose that or that. The coproduct of with coproduct of two causal loop diagrams, it'll put them sort of next to each other in a way. So what's the initial causal loop diagram? What's the initial causal loop diagram that can be uniquely mapped to any other?
It's the same.
Well, so it's a good thing to think about. It has to be unique. And if I try to map this onto this guy, I could find it here, and I could find it here, find it here, find it here. So that won't be unique. It would have potential mapping. So what sort of thing might be unique? What sort of thing? What's that? Empty causal.
What actually means, like semantics, what the meaning of that interpretation in practice.
It's
What does I mean that you're real nice?
so an empty causal loop diagram. We're not positing anything, and in fact, Yuja, you were in class yesterday.
Yeah.
Remember I said like everything by default is in an ignored state. If you have nothing, if you have no model, like everything is ignored, right? So if you have no causal loop diagram, it vacuously matches any other causal loop diagram. Just like an empty set can be vacuously mapped to any other set.
I guess you could consider that any causal loop diagram has a portion of it that is null.
Yeah. Yeah. Well, yeah, it's kind of like where the clouds go. The clouds and the stock flow or something. I know.
So it's
Empty stock flow diagram. Empty stock flow.
So it doesn't have
Yeah. Can you map maps to that? Are there any maps to that? No, except from itself.
Right.
So it's very much serves the purpose of like one that's like an empty set. Right. It's not that interesting. It's not that interesting.
Diagram, the initial value
Yeah.
is empty.
Okay. I'm gonna tell you something that maybe will make you happier.
Okay.
You can have, like, there is a category of non-empty sets where you just rule out the empty set. You can have a category of non-empty set and where the functions are maps between them. What is the initial object in the category of, well, what's the terminal object in the category of non-empty sets?
No.
Well, no, in the category of non-empty sets, what's the terminal object? What's the terminal object?
set of elements.
No, it's actually. It actually doesn't change the terminal. What's the terminal element in sets? What's the terminal element in set? What's the single set or
Set size one.
one set of size one?
Right.
Yeah. I mean, there's other sets. There's the set of single elephant, and there's a set of a single person, a set of a single flower, a set of a single rock. But like they're all isomorphic, so that we all consider them terminal objects. I mean, they're a rose by any other name is just as sweet. Potato, potato, tomato, tomato. It's basically the same thing. It's just a matter of labeling. That's all. And so that's the terminal object in set, and it's the terminal object in non-empty sets too. What's the initial object in non-empty sets? Okay.
Non-empty.
Okay, I've got to go back and because I would think it wouldn't exist.
Yeah.
No.
It wouldn't exist because there's none. But I saw another thing that said I did see something that commented that this is a category with a zero object. So the empty the set of size one would so that initial and terminal objects are the same, but that doesn't make sense because each initial object would have many mappings to any other object, any other non-empty set. So I don't see why that would be the same as they come out. Yeah. So causal diagrams, product has this flavor of like stratifying it, having all these distinctions and all these distinctions, right? That's just like for set, like product has this notion of like having all these distinctions and all these distinctions, but having both types of information captured. Co-product will have the notion of like keeping them side by side, just putting them next to each other. We'll talk about that next time. Are we good? Yeah. So okay, so product is pretty important. Its generalization pullback will be arguably even more important for our purposes when we're dealing with sheaves. So